I'm Kenneth Zammit. I'm the Group Director for the Facade Engineering team at Bureau Happold Engineering. Bureau Happold is really known for its multidisciplinary engineering practice, and we pride ourselves in making the vision viable for clients and architects from concept through to construction. Bureau Happold have been involved in a number of iconic buildings, including the main stadium for the London Olympics, the O2 Arena, and the roof of the Great Hall in London. Effectively, the facade engineering brings structural engineering, thermal engineering, building physics, lighting, acoustics, all together into the aesthetics of the building, whereas a lot of other engineering disciplines get hidden behind a veil. So sometimes we need to join together not only the aesthetics, but also structural parameters and thermal parameters, which are often pulling at different sides of the design. So bringing these two together involves quite a lot of iteration and extremely close collaboration with the architects. When we manage to get a balance among all of these parameters, this is true success in facade engineering. Over the past few years, I've seen quite a change in the demands of the aesthetic appearances by architects. I see architects looking for depth in the expression of a material finish. We can see new products being developed, particularly metallic products, which can achieve much more depth. Architects are always on the lookout for the new, the innovative look on a building. And material finishes and depth in the way the light interacts with the facade and the finish, particularly as a person walks by the building and looks at it. It's about dynamic appearances and change, but also dynamics in terms of the light interacting with the facade during the day, the night, and different seasons, which can have such a striking effect on a building. The use of steel in door and window components offers insulation and strength even under fire conditions, which few other materials can offer, which is key because facade elements need to be fabricated to very exacting tolerances. This is an example of a fire-rated door product, which shows not only the complexities of the formation of the steel product and the fabrication process, but also the composite use of different materials, the plastics used, for example, to improve thermal performance. Working with ArcelorMittal in the development of the Magnelis coatings, which have seen the use of magnesium as opposed to zinc coatings, which give much better durability. One of the surprising properties of Magnelis is that it does have self-healing properties, which means that when there is slight damage to the surface coating, it still offers the same level of protection. This is quite a game changer in terms of protection to steel products, which has very often been limited in terms of protection from localized damage. If there were one thing on my wish list that I could have in terms of pushing forward the boundaries of facade engineering, is really a commercially viable option for 3D printing of components. I see great potential for steel, particularly in the area of life cycle costing of materials. There is a great opportunity to reuse steel materials, combining technologies such as RFID to obtain provenance of material and seeing this through the BIM process to know where the material has come from and where it is going will have a very significant impact on true sustainability of materials, not only looking at carbon emissions, but seeing where the material has come from and where is it going. If it is not born in the concept of the design of the building, the tendency is that it will be more costly to demount and reuse elsewhere. So we need to be thinking of this at the earliest stage of concept design.